Okay. So this is section 3.5 on complex zeros. In this section, class, the steps to factorize everything is basically the same. There's one little minor thing that we have to change or we have to do to get the complex zeros. So that's why this section kind of stands by itself. It goes deeper into what we've already learned. So the essential questions for today are, what is the relationship between the degree of the polynomial and the number of zeros the polynomial has? Number two, how do we completely factor the polynomial? And number three, if we have the zeros along with the degree of the function or the polynomial, what is the polynomial in standard form? Okay, so those are our standard or our essential questions, and that's what we're going to answer today. So the relationship between the zeros and the degree of the polynomial is that they're equal to each other. Okay, the number of zeros will always equal the number of, or what the degree of the. Okay, so if you have a degree of 5, let's say, x to the 5th, and that's the highest power exponent, then 5 is the number of zeros you have. The degree of the function is 4, let's say x to the 4th is your highest exponent, then the number of zeros you have is 4. Okay, so that's just a quick check of, hey, do I have all the zeros that they're asking for? Okay, so just be aware of that theorem. Okay, imaginary and complex numbers, this is just a review. Imaginary numbers, remember, is just a square root of -1. Okay, whenever you have a negative in the square root, that is going to be an imaginary number. Okay, so I equals the square root of -1, and I squared is always going to equal -1. These two values are the values that you're going to be using. Okay, and a complex number, class, is just a real number combined with an imaginary number. Okay, so the real number with 2 plus I is this 2 plus, and then the imaginary part is the I, right? So 2 plus I is a complex number. -3 plus 7I is a complex number. And 6 minus 4I is also a complex number. All right? So just know that, and you guys will be good. Now, what we're going to do is completely factor everything out first and get the zeros of multiple examples. So I'm going to stop my share. And here is the first problem that we're going to do. Okay, it's P of x equals x cubed minus 3x squared plus x minus 3. All right. So the easiest, simplest way to do this without synthetically dividing is factoring by grouping. Okay, so I'm going to group the first two and group the last two. All right, do you guys remember factoring by grouping? Okay, we group them. It could be either 3 or 1. It could be 2 and 2. And then we find what's in common between the first parentheses. So what's in common between x cubed minus 3x squared? X squared. So I can take out an x squared, right? What's left over is x minus 3, correct? And the next one, there's nothing here that I can take out, right? So I'm just going to rewrite it here. X minus 3. Okay. Now, there is an imaginary one. You're right. Now I'm going to treat this as one term and treat this guy as the other term, right? Now, if I treat these two guys as two separate terms, what's in common between this term here and this term here? The x minus 3, correct? So if I take out an x minus 3 from both, here I'm left with x squared left over. Here I'm left with a 1. And that's just the 1 right there, right? There's an imaginary 1 if it's just plus x minus 3, right? So that's my complete factorization of this polynomial. Okay, so I can put p of x equals that. So I'm good, right? Now, the next part is to find the zeros. So I'm going to make p of x equal to 0. So x minus 3 times x squared plus 1. So if the product of these two terms equals 0, then I know x minus 3 equals 0, or x squared plus 1 equals 0, right? So here x equals 3, or subtract 1 from both sides, x squared equals negative 1. To get rid of the squared, I need to square root. Remember, if I square root, my left-hand side is just x, because the squared and the square root cancel out. Here, whenever I square root, it's always going to be a plus or minus. Square root of negative 1, which is I, right? So my zeros is 3 from here, positive I, and negative I. Okay? Now notice I have 3 zeros, 1, 2, 3, right? 3i and negative I. And look at the degree of the function. It's to the third. Okay? So now I know I have all my zeros and I am good. Okay? Now here's another example. Okay? P of x equals x cubed minus 2x plus 4. I cannot factor this out because x cubed and x to the first, 1 times 2 is 2, not 3. We talked about that last time, right? Where if this was, the exponent was double this exponent, then I can factor. But since it's not, I would have to synthetically divide. We first synthetically divide by using the rational root theorem. So APRR, factors of 4 over the factors of 1. Factors of 4 is plus or minus 1, plus or minus 2, and plus or minus 4. Factors of 1, I don't really need to do anything with, right? Because it's just 1. It's just going to be plus or minus 1. So this is my list for all possible rational roots, right? So I'm going to test them out. I'm going to test out 1. 1, coefficient for x cubed is 1. Coefficient for x squared is 0. Coefficient for x is negative 2. And then positive 4. Right? And I know my last number here is going to be my remainder. So I drop down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1. And that's a 3. So since there's a remainder, I got to keep going. I'm going to try 2. Okay. And since I'm going to keep going, I'm going to go ahead and highlight, box, star, whatever, this row. Yeah. Just so that my eyes go there and I know that it's this row that I'm working my synthetic division with. So I drop down the 1, 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, negative 2 plus 4 is 2, 2 times 2 is 4, 4 plus 4 is 8. No, right? But it was really close. You guys see how it's really close? Yeah, if this was a negative 2, then I would have got a 4, a negative 4, and then I would have done it, right? So I'm gonna try negative 2. Okay. So I drop down the 1, 2 times negative 2 times 1 is negative 2. 0 minus 2 is negative 2. Negative 2 times negative 2 is 4. Negative 2 plus 4, is 2. Negative 2 times 2 is negative 4. 4 minus 4 is 0. Right? So we got our list. So if x minus 2 is my root, then what's my factor? X plus 2. And then I would have, I know this starts off with x cubed. So I'm going to go x squared first. So 1x squared minus 2x plus 2. Correct? Now, since I have the x squared, I don't have to synthetically divide anymore, right? I could try and factor it. Can you think of a combination of numbers that gets me a product of 2 and a sum of negative 2? Negative 1 and negative 1, that's not a product of 2. They multiply to 1. Yeah, but yeah, there is none, right? If there is none, right, then you are done factoring. Okay, we're done factoring because that guy is not factorable. So that's my answer. Okay? It was a trick question. All right? So I'm gonna have to find my zeros. So we have our factored form here, right? The next step is to find our zeros. So I'm gonna set this up equal to 0. And honestly, class, you don't really need this step. I'm just showing you guys what it means to find out all your zeros. You could straight from here just set this up, each little factor up equal to 0. X squared minus 2x plus 2 equals 0, right? And so this one is x equals negative 2. That is one of my zeros. And in this case, class, if you can't factor it, what else can you use? Quadratic formula. Yeah? X equals negative b plus or minus square root b squared minus 4ac all over 2a. I have a slide up later if you guys don't know the quadratic formula, so just hold on tight. Okay? So for the quadratic formula, we need my a, my b, my c value. A is 1, b is negative 2, and c is positive 2. So x equals negative 2 is negative b plus or minus square root b squared, negative 2 squared, minus 4ac all over 2a, right? So I use the quadratic formula there to figure that out. And then this becomes a positive 2 plus or minus the square root of 4 minus 8, right? 4 times 1 times 2 is 8, all over 2. Oh, so this is going to be 2 plus or minus the square root of negative 4 over 2, right? What is the square root of negative 2 or negative 4? What is the square root of negative 4? Yeah, 2i, okay? 2i is the square root of negative 4. So this, I can rewrite that as 2 plus or minus 2i over 2. Okay? I can rewrite it like that, right? And so you guys have to remember, because students make mistakes on this. This is like a common mistake. This 2, the denominator of 2, goes to both the 2 and the 2i. Okay? Does not go to just 1. Does not go to, okay? So 2 divided by 2 is 1, plus or minus 2i divided by 2 is I. Okay? So my zeros here are x equals 2 or negative 2, 1 plus I, and 1 minus I. Okay, there's 3 zeros, negative 2, 1 plus I, and 1 minus I. And check this out. The degree of this function is 3, and there are 3 zeros. Okay, so that's just a quick check on what you can do, right? To check if you have all the zeros, check the degree of the function, and make sure it matches up with the number of zeros you have. All right? My third one that I have is this. Same thing, just a bigger degree. Right? So how many zeros should I come out with? 4. Right? Because it has a degree of 4. Okay? So it looks to me that we have to use the APRR here, because it would just be way difficult to factor. So I want the factors of negative 4 over the factors of 3, plus or minus 1, plus or minus 2, plus or minus 4, over plus or minus 1, plus or minus 3, right? That would be my list, correct? And now here, all the possible rational roots is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. Okay, I divided everything in my numerator by 1. I divided everything in the numerator by 3 to get these two sets of numbers. So I'm going to go fishing. 3, negative 2, negative 1, negative 12, negative 4. And just like any fishing expedition, right? You guys wouldn't go to or fishing to a place where you know that there's no fish or there's a few fish, right? You guys would go to a place where there's a lot of fishes, right? Same thing with this. Okay, think about the numbers that you're testing out, right? And test those guys out. Wait, for example, here, 3, negative 2, negative 1, this negative 12 stands out, right? It stands out like a sore thumb, right? Because it's so big. So I'm going to stay away from 1. I'm not going to test 1 unless I have to. Because I would have to have a 12 down here, and I don't think there's going to be ever a 12 with these 3 numbers. Does that make sense? Or at least something close to 12, right? So I'm going to stay away from 1. I'm going to try 2. Okay? So then I know that back number is going to be my denominator. So I'm going to drop down the 3. 2 times 3 is 6. That's 4. That's going to be 8. That's 7. That's 14. That's 2. That's 4. And that's a 0. I promise to you that I did not know that 2 was going to work. Or I forgot that 2 was going to work. Yeah. You guys got to believe me. I didn't know. Yeah. I literally, my train of thought, I just said it out loud. Yeah. So the 2 became a root, right? I tested it out. It is a root. So x minus 2 is my factor. And I have 3, 4, positive 4, positive 7, and positive 2. So since it's x to the 4th, I have x cubed, x squared, x, and then a 2. Right? Then I would have to do this over again, right? One more time. Yeah, really quick. Now that I've shown you guys a lot of examples of where we find this, factors of 2 is plus or minus 1, plus or minus 2, over the factors of 3 is plus or minus 1, plus or minus 3, right? So the APRR list is going to be plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 2/3. Okay? I'm gonna go fishing again. 4, 3, 4, 7, 2. Let's try 1. 3, 3, 7, 7, 14. I'm gonna stop because that's not gonna work, right? Once you know it's not gonna work, stop. You don't. I know the math is easy, right? But just don't spend the time doing math, says the math teacher. Let's try 1. Let's try 2. Would 2 work, class? No? So there's no negatives anywhere. So it just makes it bigger and bigger and bigger and bigger, right? So let's try, how about -2? How about if you bring a negative? -1? Let's try it. 3, -3, 1, -1, 8. Nope. -2, 3, -6, -2, 4, 3. Nope. So I'm with the 1/3. Let's try 1/3. 3, 1, 5. I'm gonna stop. Why am I gonna stop? It's gonna get messy, right? 5 is not divisible by 3. Yeah. So it's just gonna get messy from there on out. So let's try -1/3 and see if that works. 3, -1, 4, -1, that's 3. I'm still good. That's -1. 7 -1, that's 6. I'm still good. 1 -1/3, that's -2. 2 -2, that's 0. Right? So I got it. Okay. So I want to pull down that x minus 2 from the top. This factor here, I pulled it down. Let me back up. Yeah. And if x, or if negative 1/3 is my root, what's my factor? Positive 1/3, but 3x plus 1, right? And then I would have a 3x squared plus 3x plus 6. Correct? Yeah. So I got that. Now here, what can I take out? A 3. So I want to do that before I try to factor this out. Plus x plus 2, right? Yeah, so we got that, right? Now, can I factor this out? Is there two numbers that get me a product of 2 and a sum of 1? No. 2 and 1 is the only combination, right? Or negative and a negative. Negative 2 and a negative 1. That does not get me a sum of 1. So I'm done. Equals P of x, and I am good. That's my factored form. Okay? So if I want the zeros, I'm going to make x minus 2 equal to 0. I'm going to make 3x plus 1 equal to 0. And I want to make x squared plus x plus 2 equal to 0. Right? To get my zeros. Okay? So here I know x is going to equal negative or positive 2. I know that x is going to equal negative 1/3. And here I need my quadratic formula again. Yeah. So x equals negative 1 plus or minus square root b squared minus 4ac all over 2a. So that's negative 1 plus or minus the square root of 1 minus 8 over 2. That is negative 1 plus or minus square root of negative 7 over 2. Take out the negative in the square root by replacing it with I. And that is that root. Okay? Make sense? So we have 4 roots, right? Essentially. So we have x equals positive 2, negative 1/3, negative 1 plus I square root of 7 over 2. And we have negative 1 minus I square root of 7 over 2. Okay? Those are my 4 roots. And remember, we needed 4 roots. Right? So we're done. Yeah. These two roots, since they're imaginary, they don't cross the x-axis. Yeah. We're going to talk about that later. Okay? But they're not x-intercepts, just like how these guys are. Right? But these guys are not. And we'll talk about graphing later. Yeah. Okay? I'm not going to expect you to graph these guys. All right? Ever. It might be a place where I might be able to ask you to graph negative 1 plus square root of 7 divided by 2 and negative 1 minus square root of 7 divided by 2, right? Without the I. That way you can just use your calculator, right? Plug it in, you're going to get a decimal and just get it as close to that decimal as possible, right? Because that's a real number. The difference between a real number and an imaginary or a complex number is the imaginary part, right? And we're not going to be dealing with imaginary graphing, okay, in this class. All right? Great question, though. Okay? Yes. Okay, so if I go back to our slides, we did that example. We did that example. We did that example. And now we're on here. What are conjugates? Okay. Conjugates are based off of the difference of squares. The way that I remember it is, remember how a squared minus b squared broke out to be a plus b times a minus b, right? Yeah. These guys are going to be conjugates. So they're just the opposite of what you're given. So if a complex number is 2 plus 3i, we're going to keep the value of 2 and we're going to keep the value of 3. But the only difference is the conjugate is 2 minus 3i. Okay? Negative 3 plus 5i is just negative 3 minus 5i. Okay, we're just going to switch that sign. Sometimes in the middle, but sometimes it's just switching up the sign, right? So 4 plus 7i breaks out to be, the conjugate to that is 4 minus 7i. 1 minus 2i breaks out 1 plus 2i. 5i, the conjugate to 5i is negative 5i. And the conjugate to negative 2i is positive 2i. So you're just getting basically the opposite. Okay? I want to make things clear and say that we do need this when we're going through this section. And you guys find out why in like 30 seconds. All right? You guys will need that special form right there. Okay? All right. So the conjugate root theorem, notice when we did our examples, when we factored things out, right, and we got the zeros, yeah, it was always 1 plus I and 1 minus I, right? We had, I believe it was like negative 1 plus I squared root of 2 divided by 2, and negative 1 minus I squared root of 7 divided by 2, right? Those guys are conjugates. 1 plus I and 1 minus I are both conjugates, right? So what the conjugate root theorem says is, if I know for a fact that a complex number is a root, then that complex number's conjugate will also be the root. Okay? And it's going to be based, and it's because, I should say, it's because of this plus or minus. Okay? Because this plus or minus exists, they create the conjugate. All right? That makes sense? Okay? So if a polynomial has real coefficients and if the complex number is a 0, then the conjugate is also a 0, right? In plain English. I don't know if that confused you. But basically, if a complex number is a 0, then the conjugate of that complex number is also a 0. Okay? So I have two examples with finding that. So we're going to find the polynomial given the zeros of the function. Remember, if c is a root or a 0, then x minus c is the factor, right? Just remember that. Keep that part in the back of your head, because we're going to use that in about 2 minutes. Okay, and these are the two examples that we're going to do. So we're going to find a polynomial p of x that of degree 3 that has the zeros of 1/2 and 3 minus x, right? So it has a degree of 3. So I know that I need 3 zeros or roots, right? And you're given two of them, 1/2 and 3 minus I, right? So I want to put x equals 1/2 and x equals 3 minus I. What's my other 0 then? Three plus I, the conjugate to 3 minus I, right? So it's always going to be the conjugate to this, which is 3 plus I. Okay? All right? So remember, if x equals 1/2 is my root, then I know that x minus 1/2 is my factor, right? But we do not write it like this. We put this denominator up. So that's going to be 2x minus 1, right? So that's my factor when x equals 1/2 is my root. Okay? So doing the same thing, x minus the root, this is going to be x minus, and since there's two terms, I need parentheses around the 3 minus I. Okay? And I'm going to do the same thing here, x minus parentheses 3 plus I. Okay? Now my next step is I'm going to distribute the negative. So that's x minus 3 plus I. And I have x minus 3 minus I. Right? And to find the polynomial in standard form, we're just going to have to multiply all of these three. It looks easier than it looks, I promise. Okay? Using our special form, that. Okay? I have an a plus b and an a minus b here. Okay, I'll show you guys where my a is and where my b is. That's my a. Okay? And my I is my b. Plus, minus, if I multiply that out, I know I'm going to get a squared minus b squared, correct? Yeah. If I multiply these two complicated parentheses out, I know I'm going to get a squared minus b squared, correct? So my a is x minus 3. So x minus 3 squared minus b squared, which is I squared. Okay? Does that make sense? If that didn't make sense, class, honestly, there's 3 terms here, there's 3 terms here. You can multiply them and take the long route to get to this. Okay? Do you guys remember quickly how to factor this? or how to multiply this out? Yeah, x minus 3 times x minus 3, right? Or you can use a plus b quantity squared breaks out to be a squared plus 2ab plus b squared. Or a minus b quantity squared breaks out to be a squared minus 2ab plus b squared. You can use any one of these guys to factor that out, right? To multiply that out. Okay? If not, you could just go x minus 3 times x minus 3 and just FOIL. Okay? I'm going to use these special forms because it's quicker. All right? So x minus 3 quantity squared breaks out to be x squared minus 2 times x times 3, which is 6x, plus 3 squared, which is 9. Okay? I just used that special form. What is I squared? Again, -1. So negative times a negative is a positive, so I have a +1 here. Right? So here, if I clean this up, gathering the like terms, +10. And then this would travel down with me. And then here, you gotta just multiply. Okay? So this 2x first, if I multiply or when I multiply, 2x times x squared is 2x to the third. 2x times -6x is -12x squared. 2x times 10 is +20x. Right? Distributing the -1, -1 times x squared is -x squared. -1 times -6x is +6x. -1 times 10 is -10. All right, gather the like terms. 2x cubed. I see a -12x squared and a -x squared. That's -13 x squared. I see a +20 and a +6x. That's 26x and then -10. That's my function in standard form. Okay? So we are working backwards, essentially, right? To get that polynomial. Cool? Questions? No? The last one, the last example that I have is S has the degree of 4. So I know there are going to be 4 roots, right, to this. And the zeros are 2i and 3i. Wait, it has 4 roots, but I'm only given 2. What's the other 2? Huh? The conjugate, right? So what's the conjugate to 2i? -2i. What's the conjugate to 3i? -3i. So there's my 4 roots. Okay? So if 2i is my root, then x minus 2i is my factor. If -2i is my root, then x plus 2i is my factor. Same thing here. X minus 3i is my factor. And x plus 3i is my factor. Yeah? Okay. Using this guy here. Okay, a squared minus b squared equals a plus b, a minus b. A plus b, a minus b right here, right? So I'm going to use that and say x squared minus 2i squared. And I'm going to use that here as well. So x squared minus 3i squared. And I'm just going to simplify that, right? Simplify to 2i squared. 2i squared is 4i squared, right? What is I squared again? -1. So that's x squared plus 4. And here I have x squared minus 9i squared. Again, x squared or I squared is -1, so I have x squared plus 9. Right? Putting these two kind of together, x squared plus 4 times x squared plus 9. And then I'm going to simplify it by multiply it using FOIL. You can use FOIL. First are these two guys, that's x to the 4th. Outside is these two guys, which is plus 9x squared. Inside is 4 times x squared, which is plus 4x squared. And then last would be the 4 times 9, which is 36. Gather the like terms right there. X to the 4th plus 13x plus 36. X squared plus 36. Okay? Cool? And that's your polynomial. Okay? Questions? Comments or concerns? That's the lesson for 5.3.